let us solve this problem today. See, this is over here d power 4x and dt power 4 of x is equal to m power 4. Show that x is equal to c1 cos mt plus c2 sin mt plus c3 cos h mt plus c4 sin ht. So we have to prove this. So this is basically a proof. Okay, we have to prove this. See, observe that the solution is more simpler than you think. Can be written as d power x is equal to m power 4 of x. This is 1. Later this can be written as d power 4 of x minus m power 4 of x is equal to 0, and further it can be written as d power 4 minus m power 4 of x is equal to 0. So this is our third equation. We know that a square minus b square is equal to a plus b into a minus b. Okay, a plus b whole square is equal to a plus b into a minus b. Similarly, what we can do is that this is d square power square m square power of square, and we can write it as d square minus m power m square and d square plus m square of x is equal to 0. Okay, similarly we can further write it down as a square minus b square is equal to a plus b into a minus b. Similarly, we have a square minus b square form over here. We can write d plus m into d minus of m d square plus m square of x is equal to 0. Now we can see that if we equate this to 0, we get root is equal to m comma minus m. But if we equate this to 0, we get something which is called as I of m comma minus I of m. Okay, now substituting this in this equation in the solution, this only has a complementary function. It has only a complementary function. So the solution is in the form of see, it is x over here, so it will be x, and this is the derivative of t. So x has to be a function of time. It will be, since these are only the roots, so a into e power mt, because it is a function of time, plus b into e power minus mt plus c into e power im plus d into e power minus im. See, these two can be expanded by De Moivre's theorem. These two can be expanded by De Moivre's theorem, and can be, after further expansion, we can write it as something which is like c3 cos mt plus c4 sin mt. Okay, a little bit tight because it's a complex function. Okay, now let's come to this particular part. Most student gets confused that how do you write this particular stuff. So the easiest way to understand is that cos hx is equal to e power x plus e power minus of x by 2. Similarly, sin hx is equal to e power x e power minus x by 2. Now further we can write it as 2 cos hx is equal to e power x plus e power minus x. 2 sine hx e power x minus e power minus x. Now if you add this equation, let us call this as equation 2 and 3. If you add both of this, I will add over here, just see, 2 sine hx is equal to e power x minus e power minus x, 2 cos hx e power x plus e power minus x. So if you add these two will get cancelled and you get 2ex and you will get 2 cos hx plus 2 sine hx, and this 2 will get cancelled because of the common, so you get cos hx plus sine hx is equal to e power x. Okay, similarly if you subtract these two, we end up something which is like this: sine hx minus cos hx is equal to minus of e power minus x. Okay, and by some algebraic, by this subtraction, if comes over here, let's call it as 4, and if subtraction comes over here, you get cos hx minus sine hx is equal to e power x. So this is, let's see, it is equation 5. So this is our complementary function. Okay, this is our main function, what the solution actually came for us. Now substituting e power x and e power minus x over here in this equation, what you end up is something which is very simple: x of t is equal to a, this is e power mx. So if the e power mx over here means that this will be cos h of mt plus sine h of mt, okay, plus I'll write here plus b cos h of mt minus sine h of mt plus already this equation we have written as c3 cos mt plus c4 sin mt. Okay, now what we can do is that we end up with something which is very simple. Since this is cos hm, so a, and this is cos hm, b as a common hmt plus, since this is a common and b if multiplied by this is, you will get b, and sin hmt plus cos c3 cos mt plus c4 sin mt. And what we end up, see, this is also a constant, this is also a constant, so finally we end up x of t, okay, x of t as a function of, this is a constant, okay, so let's, it would be c1 cos h mt plus c2, this is also a constant, cos mt plus c4 sin mt. Okay, now see, we got the answer as c1 c2 c3 c4. c1 c2 c4 are the constants. Okay, and see what we have to prove: c1 cos mt, but over here it is c3 cos mt. No matter how, whatever are the constant, you can write whatever way you like, whatever way you choose to write it. So it can be written as by rearranging the terms: c1 cos mt plus C2 sin mt plus C4 cos h mt, sorry, C3, and finally we get C4 sin h mt. So this is our final equation. So this is our final answer for this particular problem. Okay, so this is our final answer for the particular problem. In the question it is shown that d power 4 of x by dt power 4 is equal to m power 4 of x 4 into x. Show that we have to prove this one. So this is the thing that we have to prove, and what we have done is that we have taken this equation d power 4 of x is equal to m power 4 of x. Later we can further done it, we have brought this minus m power 4x towards inside this equal sign, and then later d power 4 minus m power 4 of x, we have taken the x common, and this is our formula. This is our formula that we have applied. A square minus b square is equal to a plus b into a minus b. Similarly, this is our application, d square whole square minus m square whole square. This is law of exponents. A power m and of n is nothing but a power m n. Okay, this is law of exponents. Because of this law of exponents, I can able to split this powers as a multiple, and then d power square minus m square. So I have applied this formula, and then we have approached this one. Again we have seen that this particular inside the bracket terms inside the bracket is also in the form of this a minus b whole square formula. We have applied it over here, and then after that we have equated to 0. These are the roots that we have got. Okay, most students get confused that how you write all these things. It only comes with an experience, but for beginner it is enough that whatever roots you get, you just put a constant and then just put that root over here as m, and see b a constant and a minus m over here. Okay, and this is c, this is im over here, and this is e, this is minus im over here. Once you got this root, you can do further algebraic manipulation using De Moivre's theorem. See, De Moivre's theorem is nothing but e power I theta is equal to cos theta plus I sin theta. You can expand this using De Moivre's theorem. Okay, by expansion you get this form of constants c3 and c4. Now our hyperbolic and this is e power mt. As I have shown over here, cos hx is represented in this form and sin hx is represented in this form, and therefore 2 cos hx, this 2 comes over here, and then e power x plus e power minus x is over here, and similarly 2 sin hx and e power x minus hx is over here. Then I have shown you that over here that if you add these two terms, you get e power x as one of the and if you subtract these two, you get something which is end, which is as number 5. Okay, now substituting e power x in this term and substituting e power minus x over here in this term, what you end up is some this form of equation. That's it. Cos hmt, sin hmt, cos hmt minus sin hmt, and taking cos common, a plus b, a minus b sin hmt, and then c3 cos hmt. Finally we have come to this equation, but we see that the constants are, these constants which are over here are in different form. So what we have done is that you can write constants in whatever way you like. So we have rearranged the terms and written the constant and got the final answer. Okay, so this is the final answer for this particular solution, and if you like my explanation, please do like, share and subscribe. I will be bringing more videos for complete BS GREWAL mathematics book, and I will solve so many problems that after solving with me you will find that things are actually become comfortable. Maths will become a comfortable for you, a home zone for you. You will actually feel comfortable like that. You will feel at least home with mathematics. So that's all guys for today. See you next time in the next video. Till then, take care. Bye bye.